Alrighty, our 4.1 notes. Today we're going to start looking at matrices. Okay. So what a matrix is, it's just a rectangular arrangement of numbers in rows and columns. Okay. Now when we're looking at it, okay, the way I like to think about it to keep rows and columns straight is a building. Okay. If you've ever heard about a building, okay, let's just say we got there. Okay, and then you've got the pillars. Okay. Okay, pillars are also called columns. Okay, so columns are up and down. Rows are from left to right. Okay, now, so since we have a rectangular arrangement for these matrices, okay, dimensions is always going to be rows by columns. Okay, so M by N. We represent rows with M, columns with N. Okay, entries or elements of a matrix are just those numbers that are going to be inside that matrix. So let's say we had a 2 by 2 matrix. Okay, 1, 2, 3, 4. There's 2 columns, 2 rows, I should say, and then columns are there. Okay, so again, that's a 2 by 2 matrix. Okay, so now we're going to have these operations with these matrices just like we have with any type of number. Okay, we got adding, subtracting, scalar multiplication on matrices. Those are the ones we're going to concentrate on today. But before that, we're just going to see if two matrices are equal. So in order to have two matrices that are equal, first they have to have the same dimensions. Okay, that's a 2 by 2 matrix. That's a 2 by 2 matrix. And then from there, we're just going to go to each entry. Okay, so in this entry, this is the row 1, column 1 entry, that one in blue, 2.5. That's the same as 5 halves. Okay, don't mistake. Decimals and fractions, those are just different ways of writing numbers. Okay, so our row 1, column 2 entry, -1, -1, that's good there. Row 2, column 1, -0.2, -1/5, those are the same thing. And then our row 2, column 2 entry, 3 and 3. So since all of those values are the exact same in each entry, this is an equal matrices. Okay, so then going again to the B there, 1, 1, that's our row 1, column 1 entry. Those are not the same, therefore this is not equal. Okay, as soon as one entry is not the same, then it is not equal. All right, so performing our operations then, we're going to do addition. So when we're doing that, again, row 1, column 1, row 1, column 1. Now we're just actually going to add those matrices. Okay, and again, we got a 3 by 1 here and a 3 by 1 there. Okay, in order to add, those dimensions have to be the same. So 0 plus 1, 4 plus -9, and then finally 3 plus 8. Okay, so then actually just doing that addition. 1, 4 plus -9, we get -5, and then 3 plus 8, 11. Okay, so addition again, you need to have the same dimensions, and then you just find each of the same entry, row 1, column 1, row 2, column 1, row 3, column 1, add those up. Okay, so and then again here, on B, we have a 2 by 2 matrix, 2 by 2 matrix. Since they have the same dimensions, we can do that subtraction. Okay, subtraction has those same rules as addition. Okay, so we're going to end up with a 2 by 2. Okay, so let's go ahead. Let's do row 1, column 1, 3 minus 2. Row 1, column 2, got 3 minus 0. Row 2, column 1, 9 minus -3, which would be just 9 plus 3. And then finally, row 2, column 2, -5 minus 5. And then simplifying our answer there, we got 3 minus 2 is 1. We got 3 minus 0 is 3. 9 plus 3, we get 12. And then finally, -5 minus 5 for -10. Okay, so just go to corresponding entries and add or subtract them. Okay, now on this next one, we got a 1 by 2 matrix and a 2 by 2 matrix. Now, since those dimensions are not the same, this one is not possible. Okay, again, we need to have the same dimensions in order to add or subtract. Okay, so going to scalar multiplication then. Okay, scalar multiplication is saying we're taking that whole matrix times 6 in that first case. Okay, so in that first case, let's go here, we're multiplying that by 6. Okay, now the scalar multiplier times a matrix, we have a 2 by 2, we're going to end up with a 2 by 2 matrix. This one's saying 6 times 2. 6 times negative 3. 6 times 8. 6 times 4. Okay, and then just simplifying that there, we get 12, negative 18, 48, and 24. Okay, so again, that's how, following the highlighted blue there, that's how we get that 12. Okay, 6 times 2, you get 12. All right, now, so let's mix it up a little bit. We got a scalar multiplier on that first matrix plus this other matrix. Okay, so in this first matrix, we got a 3 by 2 and a 3 by 2. Okay, we can do the scalar multiplication no matter what. Now for the adding, we need to make sure we have that same matrix, which we do. And since we're multiplying by negative 1, I'm just going to flip the sign on all of my entries. Okay, so then plus our second matrix. And again, just lining up our entries. Oop. We have to repeat colors there. Okay. But then again, in our answer, since we're adding 3 by 2s, negative 4 plus 3, we're going to get negative 1. 7 plus 6, 13. Negative 3 plus 9, 6. Negative 3 plus negative 8, negative 11. And then so on and so forth. Okay, so again, there's our blue. There's the other blue. Here's our green, the other green, red, and purple. Alrighty, so that's a mixture of scalar multiplication and addition. All right, now sometimes we're going to have an equation that we need to solve, okay? So this is where it's going back to those equal matrices as well. We have this operation we need to do, okay? Our PEMDAs, our order of operations, does not change, okay? Let's go ahead and let's do the inside the parentheses first. So we got a scalar multiplier times that addition inside. Okay, so when I'm going to add that up on the inside, and since it's a 2 by 2 and a 2 by 2, we can do that addition. 8 plus 4, we're going to get 12. 0 plus negative 2x, that's negative 2x. Negative 1 plus 1, we're going to get 0. And then finally 2y plus 6. And then you're just going to write that as 2y plus 6. Okay. All right. So now we have that equal to this other matrix. Okay. But we still have a little more simplifying to do on that left side. We still have that scalar multiplier. Okay. So multiplying every entry by 4. So if we do that, 4 times 12, we get 48. Negative 2x times 4, that's negative 8x. 0 times 4 is 0. 2y plus 6, that quantity times 4. So again, we've got to distribute that 4 to both. We're going to get 8y plus 24. Now that is set equal to this matrix over here. Okay. Now our goal here is to solve for x and y. Okay. So since in this statement, it's saying the left matrix is equal to the right matrix. Okay, you notice 48 and 48, 0 and 0. Okay, so we're trying to solve for x. So we're going to set those two things equal to each other, and it's going to give us an equation. Okay, which we can solve for x. Okay. Okay, so and then we need to solve for y yet. So and then there's our equation again, 8y plus 24 equals 8. Subtracting that 24, 8y equals negative 16. Divide by 8, we get y is equal to 2. Oh, negative 2. So there's y, and there's x. Okay, so again, simplify, okay, just do your order of operations. Do that addition of the matrices, do your scalar multiplier, and then you're going to end up with a matrix equal to a matrix. And again, those should still have the same dimensions. And then wherever you have x and y, take that, set it equal to the corresponding entry in the other matrix, and then solve the equation from there. Okay, so that is 4.1. The next lesson will be multiplying. Multiplying is a little bit harder, but for your homework on this lesson, 4.1 book assignment. Okay, so again, with these book assignments, they're all right there. They're just questions from the book. So in this case, do 4.1 practice, and there are the solutions. So make sure you work them out and check your answers. Other than that, have a good day.